Today we are going to finally get a really big picture by putting together a lot of the things that we have learned in the past couple of months. So we are representing linear equations in many ways, multiple ways. Linear equations. Remember, linear equations in general look like y equals mx plus v. So we are going to start out with a verbal description. That is one way that we can represent a linear equation. We're going to use that verbal description to write an equation the second way to show a linear equation. All right. This says that the football game charges $10 admission and sells hot dogs at the concession for $1.50 each. So before I write the linear equation, I know I need m and b. M is the thing that happens many times. We have $10 admission and $1.50 each for hot dogs. The thing that happens many times is the $1.50 each. So m is 1.5. If a verbal description gives you a slope as a decimal, you can keep it as a decimal. You could also change it to a fraction. Either way, the values will be the same. Okay. That means that b is where we begin. We begin by paying $10 to just get into the game. Now that I know m and b, we can write the equation. We'll have y equals, instead of m, we write 1.5 x plus b is 10. Now we're going to use the equation to create the table. The table will just show us a bunch of the ordered pairs. Remember, the left side on a table is x, and the right side is y. So we're using the equation y equals 1.5x plus 10. But now we know some x values. So first I can say y equals 1.5x plus 10, but x is going to be 0. So I can put a 0 in place of x. Well, 1.5 times 0 is 0 plus 10. 0 plus 10 is 10. I can do that same exact process. 1.5 times the x value plus 10. Now the x value is 1. Well, 1.5 times 1 is 1.5 plus 10. We did 1.5 times 1, and now we're adding 10, so that's 11.5. Just stopping and talking about this, that seems like an awful lot of money, $10 for no hot dogs. But if you look at the verbal description of the equation, this makes sense because that's not $10 for hot dogs, that's $10 to just get into the game. Now when we're buying hot dogs, we're adding just $1.50 every time we get one more hot dog. So think about what the next price would be, the next total cost here, if we're just getting one more hot dog. Now let's use the process, now that we've thought about it, let's use the process to mathematically see if we were correct or not. The equation is 1.5 times whatever x is plus 10. X is 2 now. So we've got 1.5 times 2, which is 3. Now we still have plus 10. 3 plus 10 is 13. Now we had one more hot dog from 1 to 2, so we should have gone up by just 150, and we did. 50 cents gives us 12, and then the extra dollar is 13. Now that's not always going to work because you're not always going up by 1. In this next example, we're going to go up by 3 hot dogs. So you should still use the equation even if you can add the slope quickly in your head. We've got 1.5 times whatever x is plus 10. X is 5. 1.5 times 5 is 7.5 plus 10, and 7.5 plus 10 is 17.5. Now we'll have y equals 1.5 times x plus 10. X is 10. 1.5 times 10 is 15, and 15 plus 10 is 25. We used the equation and plugged in x values to complete the table here. Now we're going to use the table to create the graph, the fourth way that we can see a linear equation. We're going to need all of the ordered pairs, so I'm going to write those off to the side. The first ordered pair, x comma y, is 0, 10. Then we have 1, 11.5. 2, 13. 5, 17.5. And 10, 25. You'll notice that these graphs don't have any numbers. So what we're going to do is create our very own scale. Here is the x-axis, and these are our x values, 0, 1, 2, 5, 10. Here is the y-axis, and here are our y values, 10, 11.5, 13, 17.5, and 25. We need to keep that in mind when creating our scales, because we need to be able to show all of the values no matter how large they are. So for our x values, we need to get up to at least 10, and for our y values, the biggest one is 25. We need to at least see 25 up here. Please, please, please remember that this is the origin. Where the x-axis and the y-axis meet is the origin. So this is 0, 0. Now, if my biggest number for x, the green axis, is 10, I think I can get away with counting by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I have at least 10 up here. On my y-axis, if I count by ones, there's no way I'm going to be able to get to 25 without adding extra lines. If I count by 2s, that would get us 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, which is still just a little too short. So maybe we'll try counting by 3s. This would be 3, 6, 9, 12. Every line is just adding 3 more. So here's 15, 18, 21, 24, 27, 30, and 33. Remember, from one line to the next, you're just adding 3. So if you get stuck, just keep adding 3s. You don't have to actually know all of your 3s off the top of your head. Alright, now that I have my axes labeled, we're ready to plot points, which we're already pretty good at. The first ordered pair is 0, 10. The x number has to be 0, so here's a 0, and the y number has to be 10. 10 is between 9 and 12, and it's closer to 9, so maybe I'll put that right there. The next ordered pair is 1, 11.5. Green number is 1, blue number is 11.5, which is close to 12. The next ordered pair is 2, 13. Green number is 2 and the blue number is 13. 13 is between 12 and 15, but it's closer to 12. The next ordered pair is 5, 17.5. So the green number is 5 and the blue number is 17.5, which is between 15 and 18, but it's closer to 18. The last ordered pair is 10, 25. The green number is 10, and the blue number is 25, which is between 24 and 27, but probably, or it is closer to the 24. So between the 24 and 27, but closer to 24. Now that I have all my points plotted, we can just connect them with a straight line. Now we can see that this is linear. We know it's a linear equation. And we also see it's non-proportional. It doesn't go through the origin, which we knew from the equation again. So first we used the verbal description to make the equation. Then we used the equation over and over and over to fill out the table. Then we used our table to make a list of ordered pairs that we plotted on the graph. Before we plotted our ordered pairs, though, we had to make sure that our axes were scaled appropriately. That was the probably most challenging part of this assignment today, or lesson today. Looking at the next problem, this says the car wash charges 25 cents per minute to use the vacuum. So I've got 25 cents per minute. Before I can write the equation, I need M and B. M is many times, and B is where we begin. Now, when I begin paying at a car wash, I haven't paid anything to use the vacuum yet, so I'm beginning probably at 0, which makes sense because 25 cents per minute happens many times, so 25 cents or 0.25 25 hundredths is the slope. And there's not another number there. That's because I haven't paid anything to just drive up to the car wash, besides money and gas. Now that I have M and B, I can write the equation. Y equals M, 0.25, X plus B. I could write plus 0, but that's not going to change the value. So instead of writing plus 0, I'm just not going to do that. There we go. Okay. Now that I've got the equation, I'm ready to create my table. I'm going to use the equation y equals 0.25x over and over and over using these x values to find the missing y values. So we'll have y equals 0.25 times x. The first x value is 0. Well, 0.25 times 0 is 0. Now I have y equals 0.25 times x. X is 2. 0.25 times 2, 25 cents, 2 quarters is 50 cents. Next we have y equals 0.25 times x, and now x is 5. 0.25 times 5, or 5 quarters, is $1.25, or 1.25. Now we have y equals 0.25 times 10. 0.25 times 10 is 2.5. Next we have y equals 0.25 times whatever x is. X is now 15. And 0.25 times 15 is 3.75. Now I'm ready to write out a list of my ordered pairs. We've got 0, 0, x, y, so 0, 0, 2.5, 5, 1.25, 10, 2.5, and 15, 3.75. My x-axis, the biggest number is 15. If I count by ones, I'm not going to get to 15. Maybe I can count by twos though. When I'm counting, I remember that this is the origin, so that's 0, 0. I'm going to try counting by twos. This will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. My y-axis needs to get up to at least 3.75. So I'm going to count by, let's count by something smaller than ones. Let's count by halves. If I count by halves, that'll make this more spread out, and it'll make the picture look better. But also, let's stretch our brains a little and count by something other than ones. So I have got 0, then that would be 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, and 5.5, or 5.5. Now I'm ready to plot my points. 0, 0 is the origin, so I'll put a point at the origin. 2, half. So here's the line for 2, and there's half. Now I've got 5 and 1.25. 5 is between 4 and 6, and 1.25 is between 1 and 1.5. So about right there. Next I've got 10, 2.5. Here's 10. There's 2.5 on the y-axis. And we've got 15, 3.75. 15 is between 14 and 16. And 3.75 is between 3.5 and 4. Now that all the points are plotted, we can connect our dots. In this graph, we see that this is linear, which we knew that by the equation. And we see that this is proportional, and again, we know that by the equation because this looks more like y equals kx than y equals mx plus b. Another way we can say this is proportional is that it varies directly, or it represents direct variation. That is all the notes for the first day of multiple representations. For homework, looks like identical to this, except I just made it really, really big. So it is 2 pages, but it's just 2 questions. Just 2 questions. As always, if you have concerns or questions or comments about the video, feel free to message me on Schoology, send me an email, or you can drop a comment on this video, and I will be glad to get back to you as soon as I can.